introduction, sir.
Yeah, good evening.
Yeah.
To one and all who has been present here. Like Mr. Sundar said, being a Saturday, I think all of you must be having a different mood. But knowing the speaker today, I think he will keep us all engaged, and then all of us will be attentive. I know Mr. V V Iyer when I was with Lucas TVS, and he used to come for AU TVS Center for Quality Management. I also happened to be part of his class, and it is wonderful. We learned statistics from him. Thank you, sir, to have you here today. And just to give a brief about ISQ Chennai chapter is just 2 years old, and we just had a recent annual conference in Chennai in the month of December, and which was a very mega event. And I have to thank all the members of Chennai who have made it a great one. And in fact, this current knowledge sharing session today, we expect not only the manufacturing people, we also want people from outside this manufacturing sector also to come and listen to you, learn, and take away something for their own industry. That we have organized for this. Thank you for being with us, sir. I thank everyone for being with us, and let us have a wonderful session with you. Thank you.
Thank you.
Thank you. Thank you, SRK. Good evening, friends. This is Sundar Rajan. I'm sorry I'm not able to unmute my camera because I'm under a double whammy. There is a power cut and this one is not kicking in inverter, so it's very dark. So it's better that I stay muted on the camera. I hope all of you are able to hear me. Okay. So it's, can you hear me, Prabhakar?
Yeah, I can hear you.
Yes,
okay.
yes.
Okay.
Yes.
So it's my privilege and it's my pleasure to introduce my teacher, my counselor, my co-counselor, and above all, my very good friend, Professor V V Iyer, for this in this session, right? As SRK said, when most people know the speaker, then what do you introduce about them? This is a tricky situation I'm in. But I thought let me share his introduction through my own personal experiences also. Professor Iyer's educational career, as well as is a good part of his early professional career, were completely intertwined with Indian Statistical Institute. I think especially SQC and OR unit, as many of us know. He, apart from his MStat, Professor Iyer also did his PG diploma in SQC OR, as well as his fellowship in quality management from ISI. And it is no wonder that ISI absorbed him into its ranks as a teacher, professor, and if I'm not mistaken, he rose to the level of a dean for the ISI SQC OR unit in Chennai, as we know. And during this tenure, a long tenure of more than 20 years with ISI, Professor Iyer had also contributed in various assignments with the industry for ISI, teaching many of us about on statistics and enabling us to apply statistics to get better with our business processes. And apart from counseling with the industry, Professor Iyer is also associated with institutions like AUTVS and other institutions. He was being associated with them as a faculty member and so on, and thereby contributing continuously for the spread of the statistical mindset and application within the industry forum. And after this long stint, during which I think he was largely associated with the manufacturing, he took a break from manufacturing away and joined TCS as a AVP in their learning and development division. And these were the early days of data science, and Professor Iyer contributed immensely by creating many models, statistical models through TCS, especially in the non-manufacturing sectors or non-manufacturing departments also. which is what I think today he will be sharing with us to improve our knowledge. And after his stint with TCS, he became an independent counselor and is continuing his contribution to various industries in different sectors to improve data application. And in the current days of big data, I think we need a solid person like Professor Iyer for us to make sense out of the mayhem of data science. And above all of this, in my opinion, the biggest feather in the cap for Professor Iyer would be the fact that he was always being the first referral from Professor Washio. SRK will know it. So whenever Professor Washio's clients had to learn statistics, he would always refer them to Professor Iyer. Okay, and it is no mean
Absolutely.
point, no mean task to gain that kind of confidence with someone like Washio-san. I think this is, to me, this is possibly the biggest feather in Professor Iyer's cap. And today, Mr. Iyer, we are privileged to have you here with us to share with us the knowledge of statistics beyond the shop floor, because shop floor thing is now become rote. So what do we do beyond the shop floor is what we would like, are eager to learn from you. So the session is now over to you, Professor Iyer. Please take over the session. Thank you, friends, and let's enjoy the session. Professor Iyer, you can take over the presentation.
Okay. Thank you, Mr. Sundararajan. Am I audible? Is it clear?
Sir. Yes, sir.
Yeah. A small background. During one of our conversation with Mr. Sundararajan, who is my friend come colleague. I call him a friend because already he told you that we know each other for more than 25 years. And also call him a colleague because we work together in several industrial projects. So during one of our conversations sometime last month, he was mentioning to me, well, a lot of statistical tools are applied in manufacturing. We know many basic tools as well as some of the advanced tools are extensively used in manufacturing. But that much application is not visible in other functional area. So is it possible for us to have some kind of a knowledge sharing session in terms of application of the tools in other functional areas as well? So that was a kind of a mention Mr. Sundararajan has made to me. I also thought over it and then I said, okay, fine, we can make an attempt. We'll try. So what I have attempted was, with my limited knowledge and experience, I have attempted to summarize the tools, what we apply in manufacturing, the tools, some of the basic as well as some advanced tools, what kind of application we can think of in other functional areas as well. So that's how we are here today. So in this session, what I am going to talk about or what I am going to present to you is just a summary of the possible applications of the basic tools as well as some not so basic tools in other functional areas, such as, apart from manufacturing, such as marketing and sales, purchase, human resources, customer service, material control, maintenance, safety, etc. In other functional areas, how we can think of applying these tools, etc. So that's what I have just summarized. Of course, the scope of the session, I'm not going to go into the detail of any of the tools. Maybe I'll just give you what is the tool, what it does. So basically, the scope of the session is going to be what functional area, what kind of a tool that can be used, and what are the possible situation or the kind of, some performance characteristics that we can apply these tools, and possibly the way that we can make use of these tools. So that is what I have summarized, and that's what we are going to discuss, or I'm going to share with you. So with this scope, let me go into the session, and I will go to my PPT presentation so that I can show you some slides. Yeah, statistical application in non-manufacturing area. And as we all know, statistics, just I'm recollecting, statistics is a science of collecting the data, analyzing and summarizing the data, do the appropriate analysis, draw conclusions or valid inferences, and then acting on those inferences. In short, you can say that how we can make more objective decisions. So we are going to deal with data collection, data analysis, etc., etc. And in a very, very broad sense, when we talk about data here, mostly we are going to confine ourselves to numerical data. I'm not going to talk about verbal data here. So we are going to confine ourselves to numerical data. When you talk about numerical data broadly, these are the types of data you deal with. The types of data and the
Sir, Iyer, can you go to full screen mode, sir? Can you go to full screen mode? Can
Oh,
you go to
sorry,
the
sorry.
full screen mode?
I understand. Yeah.
Not, sir. Yeah.
Yeah, clear.
Thank you.
So depending on the measurement scale you use, normally we call the data into two types: non-metric or qualitative type of data, or the metric or quantitative type of data. Non-metric or qualitative, you have again two categories: nominal scale and ordinal scale. Whereas in the metric or the quantitative data, you have interval scale and ratio scale. Nominal scale means just a kind of, classification. Let us say male, female, smoker, non-smoker. Your color of the eye is blue, brown, or black. So just a kind of, a kind of 0, 1 or 1, 2, 3, something like that. Here the numerals don't mean anything. They are just used as codifiers. The numbers have no meaning here. It's only categorization. That is the nominal scale. It may have just two categories or more than two categories. Whereas ordinal scale is ranking scale. Here the numbers have some meaning, in the sense, when I say, let us say I'm ranking something in 1 to 10, and understanding is 10 is the largest and 1 is the smallest. So obviously 2 is more than 1, 3 is more than 2, etc., etc. That's how it is a kind of a ranking scale. All of us are familiar. That's what is called the ordinal scale. Whereas interval scale and ratio scales, where we use some measurement device and then we get a direct numerical value. Interval scale and the ratio scale. So these are the type of data we normally deal with in our statistical analysis. Now with this, the various tools that we use, all of us are familiar with the basic tools and also some advanced tools we may be using. So for the benefit of everybody, I have just quickly mentioned the name of the tool and then the purpose of each one of these tools quickly, and then we see where possibly we can apply, etc. The basic QC tools, all of us we know: check sheet, histogram, Pareto diagram, control chart, graphs and trend charts, not charts, trend charts, cause and effect diagram, stratification, and scatter diagram. These are called the basic 7 tools, and all of us are familiar. Out of these tools, if you look at it, all of them, almost all of them, all are graphical in nature, and except cause and effect diagram, all are data based. Cause and effect diagram comes from your experience and your kind of viewpoint, etc., etc., which later will be validated by your data. So except the cause and effect diagram, all are, of course, stratification is also another concept, but still you do based on certain category you classify, etc. So except cause and effect diagram and stratification, all the other tools are data based tools. Now, what is the purpose of each one of these tools? We'll quickly recollect. Check sheet is basically to collect data very effectively and efficiently. It is a kind of a data collection format, and one of the very effectively used check sheet is the concentration diagram, where you try to see where the mistakes or errors or defects, etc., are concentrated. There are various types of check sheets, and you can kind of design any check sheet depending on your purpose, objective, etc. So it is basically a data collection format, which makes the data collection process simple, easy, etc. Histogram is a kind of a bar chart type of a tool, which tries to understand the variation pattern in a measured quality characteristic. That is our quantitative data, either interval scale or ratio scale. When you have some measurable data, because variation is always a part of any process, no process can give you identical output. So how the variation comes, we try to understand. So histogram tries to capture the variation pattern in a measured quality characteristics, and it is generally used for quantitative data. Pareto diagram is a very generic graph, can be used in many occasions, but in industry mostly it is used for identifying the defect concentration, error concentration, etc., etc. So basically the purpose is to identify the major few ones, the vital few from the trivial many. So that's the purpose of Pareto diagram. And control chart is, or that kind of what you call it as the SPC, process control chart, to identify the presence of any assignable cause or abnormalities in a process. Every process has some variation, but normally when all the process conditions are remaining more or less same, still you have variation which has some fluctuation. So you try to capture in the under normal condition what kind of variation you have, and in that process any abnormality comes, it gives an indication. So identify the presence of abnormalities in any given process. That's where the control chart will help you. And cause and effect diagram, of course, it tries to enumerate all the suspected causes associated with a problem and try to link them logically. Enumerate all the suspected causes with a problem and try to logically link them, and then group them under broad categories like man, machine, material, etc. Similar things you can also, the broad categories you can think of in other areas as well. Then you have a concept called the stratification, that is to classify the data according to the originating source. Sometime the data, if it is presented in a full form, you may not be able to understand very clearly. So if you stratify the data according to the originating source, contributing sources, etc., etc., maybe you are in a better position to interpret the data in a better manner. So stratification is a kind of a data classification method based on the originating sources. And the last one is the scatter diagram. Here you try to examine whether any possible relationship exists between two characteristics. One may be the output characteristic, another may be the process or the input characteristic. Is there a relationship? In this case, of course, both the output characteristic and the input characteristic, they must be measurable. So scatter diagram tries to examine graphically, is there any possible relationship? Is it worth examining further? So it gives a kind of a quick idea about the existence of possible relationship between two measured characteristics. So these are all the basic tools which we are all familiar. Now these tools are day in and day out we have been using in the manufacturing. And apart from these tools, we also have not so basic tools which like the next level statistical tools like testing of hypothesis testing, under which you have the various type of testing like z-test, t-test, chi-square test, analysis of variance, correlation and regression analysis, and design of experiments, etc. These are all the next level tools, not so basic, but the next level tools. So in the testing of hypothesis, basically what we try to do, you have some kind of a, especially in the cost validation, you suspect there is the y is affected by some x, one or more number of x's, right? So that has to be validated. So that is where you formulate statistical hypothesis, then you collect data for verifying such hypothesis, then do some statistical analysis and validate that. So that's where you use all this kind of test. Z-test and t-test generally you use to see the relation between x and y, where x is a categorical variable having two categories. Is there a difference between kind of two groups? Is there a difference between two different types of methods? Is there a difference between two different types of training, etc. like that? So x is a categorical method 1, method 2, or you say that process 1, process 2. So this is a categorical variable, whereas y is a measured characteristic. So is there a relation between x and y, where y is a measured characteristic and x is a categorical variable having just two categories, two groups, two suppliers, like that. Whereas as an extension of t-test is what is ANOVA, to see the relation between x and y, where x is a categorical variable and y is a measured variable, where you can have more than two categories. Three groups I want to compare, three methods I want to compare, three suppliers I want to compare, like that, or three or more. So ANOVA is an extension of t-test where you try to relate x and y, where y is a measured characteristic, whereas x is a categorical variable having more than two categories. And chi-square test is generally applied where you try to see the relation, or say a more appropriate word, is there an association between two variables where both are categorical, to examine the relation between x and y where both x and y are categorical. X is also a categorical variable, y is also a categorical variable. For example, x is a person is a smoker or a non-smoker. Y may be whether he had a heart attack or not. So have incidence of heart attack, is it influenced by the smoking habit? So whether a smoker or a non-smoker is a categorical variable, whether you had a heart attack or not. So this kind of a thing. Is age has any influence on the type of music you like? You have different age groups like teenage, you have, let us say, young age, then you have middle age, you have senior citizens. You have different type of music like, let us say, Hindustani, classical, Western, film song, etc. etc. Has age has any influence over the type of music you like? So here both are categorical. Type of music you like, that is also a categorical variable. The age group you belong to, that is also categorical. So these are all the situation where chi-square can be used, where you try to build relationship between x and y, where x is categorical and y is also categorical. And of course, design of experiments to examine the relation between y with several x variables. X may be categorical, some X may be measurable or quantitative, etc., based on experimental data. Design of experiment is you do some experiments and then based on the experimental data, you examine the relationship between several X variable. Out of the several X's, what we have examined, which are those X variables which are really influencing Y. So here you are trying to relate a single Y variable with several X variable. Some of them may be categorical also. The difference between the experimentation in the experiment, you induce changes on the X variable. You deliberately make changes on the X variable and see the effect of those changes on the Y variable. Sometime you may not be able to conduct experiment, and in such cases you use what are called observational data. So in general, data source can be an observational or through survey or from an experiment. So when you have an experimental data where you induce changes, deliberately make changes on X's, and then when you see the effect of X on Y or the several X's on Y. So design of experiments can be made use of. So these are all some of the next level tools. And apart from this, also in industry, some you can use what are known as multivariate tools. Multivariate tools or multivariate data, what is it? Multivariate data analysis equal to basically all the statistical methods that simultaneously analyze multiple measurements on each individual or object under investigation. On every sample point, you take multiple kind of characteristic. You study multiple characteristic. For example, on a person, I may collect several information like his height in centimeter, his weight in kg, his blood pressure level, whether he is a smoker or a non-smoker, whether he is a vegetarian or a non-vegetarian. Like that, there are so many information available on every object. So simultaneously, I collect several information on every individual or every object under investigation, and then we try to analyze that multivariate data. So all the statistical tools which are dealing with multiple measurements or multiple variables, they are all called multivariate tools. Generally, these are used for explanation and prediction and hypothesis testing, etc. Some of the commonly used tools in industry, especially in the non-manufacturing area, these are all some of the tools which you use frequently. Multiple regression and multiple correlation, multiple logistic regression, conjoint analysis, cluster analysis. Of course, I have not given the entire list, but some of the commonly used tools, multivariate tools: multiple regression, multiple correlation, multiple logistic regression, conjoint analysis, cluster analysis, etc. Now, what does each of these tool, what does it do? We'll have a quick review of this. Multiple regression is similar to your simple regression. In the simple regression, from the scatter diagram, you develop a simple regression. If there is an X variable, there is an Y variable. Y is the output, X is a suspected influencing variable. So you are trying to express Y as a function of X. So here, there is only one predictor variable X is involved. One predictor variable X is involved. So that's what is called a simple regression. You are relating Y with just one X, whereas multiple regression is an extension of a simple regression to examine the relation between a single metric dependent variable. Metric means quantitative variable. Y is quantitative, measurable variable, presumed to be related to two or more metric independent variable. So you have a Y, you have x1, x2, xk. How Y is kind of influenced by x1, x2, xk, or all the x's influencing y, or only some of them. So which are those x's, etc., etc. That is what it tries to build, a kind of a mathematical relationship or a statistical relationship. I will rather put it as a statistical relationship. I don't use the word mathematical relationship because mathematical relationships are exact, whereas in the statistical relationship there is an uncertainty. So the multiple regression is a statistical relationship where we try to build a model relating y with several x's, x1, x2, xk, etc. Now, as an extension of, or as a subclass of multiple regression, you have a special type of regression called logistic regression. In the logistic regression, the only difference is the y variable is a categorical variable. Y is not a metric variable. In the general multiple regression, you have, 1 minute. In the general multiple regression, y is a metric, is a measurable characteristic, whereas in the logistic regression is non-metric. Y is like 0, 1. A potential buyer, the purchase decision, will he buy the product or will he not buy the product? An individual, will he stay with the organization, will he quit the organization? In a kind of a financial institution, will he be paying the loan regularly, or he will default it? So the y variable is a categorical variable, 0, 1 type, 1 0 or 1, 1 or 0, whatever it is you call it. Of course, you can have more than two categories also in logistic regression, but the simple logistic regression, y is having just 2 categories. So it's a special case of multiple regression where y is a non-metric variable. Conjoint analysis is a kind of similar to how we use a DOE in a manufacturing environment. They try to use in the kind of a new product, service development, etc. It's as an application of DOE in the market research surveys, etc., etc. So it's similar to DOE used in the new product or the service development, allowing for the evaluation or complex products while maintaining a realistic decision context for the respondent. It is basically used to understand the respondent's preference, that is customer's preference for the product and services. That is, the product may have several attributes. Each attribute may have several levels, like in the normal DOE talk about factors and levels. The similar way, the product features and several levels for the product features. So what the customer preference is, so that while you kind of develop a product, all these things you can take into account. So conjoint analysis is a kind of a DOE application during the market survey. In fact, they use the fractional factorial design most commonly. So it's used to understand the respondents' preferences for products and services. In doing this, the marketeers or the market research group, they try to determine the importance of the attributes of the product as well as the levels of the attribute. So it's similar to our DOE application in the market survey areas. And cluster analysis is basically an analytical technique for meaningful subgroups of individuals or objects. You have a set of objects or a set of individuals. On each individual, you have several measurements made. Let us say you have n individuals, and each individual you have p number of measurements. So with reference to these p measurements, how the individuals are similar to each other. So the similar objects or the similar individuals will be grouped or put into one group. So we try to form a kind of groups, disjoint groups of n individual based on p variables based on what is known as some kind of a similarity or dissimilarity, whatever you call it. So that is what the cluster analysis. So normally they do the customer segmentation, etc., in the markets research or the retail research, etc., etc. So cluster analysis is another area where you try to, the groups are not known initially. We only know there are n individuals. On each n individual, you have p measurements. So based on the p measurements, we try to see the similarity between the individuals and try to group them and put the n individual into some, maybe you have 5, 6 disjoint groups, etc., etc. So that's what the cluster analysis is all about. So this is how basically some of the tools are used. Now we see how the simple tools as well as some of these the not so simple tools can be used in the areas apart from the manufacturing. We'll quickly go through that. And of course, the marketing and sales, if you look at it, Pareto diagram, we all know in the possible applications area, there are so many ways that you can use the Pareto diagram in the sales related concept, inquiries from the ads, etc. So we can always do the Pareto diagram based on some criteria, maybe plant or store wise, area wise, customer sex, product line wise, population density, etc., etc. So the criteria may be various things. So we can use the Pareto diagram and inquiries from the ads. These are all the possible application area. Then we can use the trend charts for the claims, mandatory recalls, returns, amount of field service, amount of repeat service required, etc. So these are all the simple tools we can use, the trend charts, Pareto diagram, etc., etc., like as we do in the manufacturing. The DOE application, similar to the conjoint analysis you can do here, response to ads, conduct a designed experiment on those factors that get most of the responses for our ads, the highest number of quality responses or the highest amount of sales, etc. Among the factors, you can, depending on what factors you think that may affect the response to the ads, that those things can be included. Could be the magazine, ad positioning, size of the ad, colors used, etc. With all those things, we can do some kind of experimental data. We can do that. Correlation analysis, scatter diagram, etc. Number of quotes versus the sales. Is there a relation between the number of quotes versus the sales? How we can use it? If there are relationship between the number of quotes from a given period and the sales volume from those quotes after 6 months or after 1 year, etc., etc. Then visitors to display booths. Suppose you have some kind of, you have participated in some kind of a fair or the kind of, some kind of exhibition, etc., etc. So the number of visitors to display booths at the trade shows versus the sales volume afterwards. So look at these measures, which will help to determine whether it is worth participating in such a kind of a trade show, etc., etc. So in this kind of areas, you can use correlation analysis and multiple regression. Possibly you can use the sales volume versus, in a retail outlet, they try to relate the weekly sales volume versus the unit price and the amount spent on advertisement every week. How the price of a retail item, right, it fluctuates, and also they spend on ad. So how much money is spent on ad weekly, and what is the unit price? Is the sales volume affected by unit price or the amount spent on the advertisement, etc.? Then customer satisfaction versus to satisfaction with a specific aspect such as the delivery, ordering, appearance, packaging, etc., etc. You have the overall satisfaction score, and also you have the satisfaction scores for individual components, etc., etc. So how this kind of things are related. For instance, in a customer satisfaction survey, you might ask how the overall satisfaction is related to satisfaction with reference to a specific aspect such as delivery, ordering, appearance, packaging, etc. Similarly, the logistic regression can be used for the purchase decision of a potential customer, purchase behavior versus the socio-economic variables, etc. So you have a kind of several other variables like age, income level, or the kind of a location, etc., etc. And will he buy a product or will he not buy a product? So logistic regression kind of a thing can be used to predict a potential buyer based on several socioeconomic background variables, etc., etc. That in fact that is what they try to do. Where here a person based on the socioeconomic or other background variables, whether the person is likely to buy a product or is not likely to buy a product. Right. So here it is a 0-1. So what is really related is the probability of a person buying a product versus the probability of a person not buying a product. So the probability is what is related based on some kind of a model, the logistic model, and wherever those customers who have a higher probability of buying, possibly even in your kind of in this telemarketing and all, they focus on such customers. That is, you don't have to kind of your ad effects on every general magazines, etc., etc. You can also concentrate who is likely to buy your product based on certain socioeconomic variables, and then concentrate on such specific customers where you have a higher kind of probability of buying. Similarly, in the financial institutions, they have whenever somebody approaches for a loan, they collect so many background information, socioeconomic background information, etc., etc. And already they have a database uh, whom all they have sanctioned the loan, who are all the regular repayers, who have all defaulted. So they have already a kind of based on the database a functional form built. If these are the condition, the chance of he paying the or repaying the loan regularly, the chance of repaying is high, or the chance of repaying is low, he is going to be a defaulter, etc., etc. Such things can be very easily predicted, and based on that a new person approaching for a loan, the financial institution may decide, yes, you can sanction the loan or you need not sanction the loan, etc., etc. So the logistic regression is one thing which is very much used in such kind of areas. So multiple regression and logistic regressions are quite powerful tools for predicting both metric Y as well as non-metric Y. Conjoint analysis, I was telling you, another kind of important tool they use in market research, product testing, ad testing, etc. Often market research is used to evaluate different combinations of the product features, or how well the advertising works, or what are the effect of different combinations of media is on the advertising impact, etc., etc. The primary aim of the conjoint analysis is especially when you do it online, is to set distinct values to the alternatives that the buyers may consider when making a purchase decision. That is, you are trying to develop a product and you are trying to do a survey and you want to know the customer preferences, and you have several attributes and you have set certain levels for the attributes, and then you try to give some kind of survey to get the preferences. For example, to make it a little more clear, suppose let us say I want to have a kind of a smartphone manufacturer. You would like to do a market survey, right? So one is possibly one of the product features, maybe the color. So he has the for the attribute color, he may have several levels like brown, blue, black, etc., etc. So several attributes of the attribute, I mean several levels for the attribute color. Then the price range, maybe he can define some levels. And what should be the screen size, he can define. So screen size is an attribute, color is an attribute, price range is an attribute. For each of these attribute, you can define levels, and then you can conduct a survey. So generally the respondents are given a fractional factorial design of profiles. For example, if each of these attributes has, let us say, 3 level, suppose you have 3 colors and 3 price range and 3 screen sizes. Totally, it will be 3 into 3 into 3, 27 combination. But all the 27 combination need not be tried. So they can just finish it off with a 9 combination, kind of a fractional factorial of a 3-cube design can be designed so that the effect of these attributes can be easily evaluated. So generally the respondents are given a fractional factorial design of profile, each of which is described by the levels of the features it contains, and were asked to rank. So the respondents will rank each of these profiles, and based on the data, so what is the customer preference, which color most of them choose, which screen size, at what combination is likely to hit the pay a hit in the market, etc. Such kind of analysis they do in the market research. So it's an application of fractional factorial design in deciding the product features and a kind of combination of levels of the features, etc. Like similar to what we do in the shop floor, the factors and the levels, and then we try to find out the optimum combination of the levels of the factors that you can correlate with that kind of a similarity. So these are all some of the applications in the marketing they do. And cluster analysis is one of the popular analysis where they try to segment the customer segmentation based on the preferences or the various products. So or otherwise they may also kind of customer profiles they can collect, and then they can group the customers whom are similar, etc., etc. So customer segmentation can be easily done using the cluster analysis. So basically cluster analysis is a grouping of individual based on several variables based on some kind of a similarity or dissimilarity measures, etc. So these are all some of the possible applications that you can we can think of in the marketing, sales area, etc. Then when it comes to human resources, of course, some of the basic tools you may be already familiar with. Check sheet, the new employee training, what are all the various aspects on which he has to be trained, you can create a check sheet. Similarly, for interviewing purposes, what are all the kind of interviewer in what are all the topics to be covered, etc., etc. Some kind of a check sheet you can make. And Pareto diagram, especially the absenteeism analysis, look at the absenteeism by the criteria like plant area, department, day of the week, month, individual, job title, shift wise, etc. Such kind of analysis can be done. Then the grievances activity, again similar thing, Pareto you can do for grievance activity. These are all the possible application area. Trend chart for absenteeism, look at the trends in the absenteeism over time. Then recruitment time, keep a trend chart for the length of time it takes to recruit a candidate for a particular position, right? For a, let us say, a middle level position or a senior level position, how much time does it take? So you keep a trend chart. In the large firms, the separate charts for different job or the job profiles, etc. X-axis represent the first recruitment took how much time, second recruitment took how much time, etc. Based on this, you can decide kind of whether it is showing an increasing trend or a decreasing trend, or somewhere near the average we are there, can we reduce it, etc., etc. So trend chart for recruitment times, etc. Similarly, you can kind of number of absence absenteeism week wise or day wise or this thing. Here you can use an attribute chart, like in the manufacturing use the for the defect count you use what is called a C chart. Similarly, here also you can use C chart or U chart, because your absenteeism rate, because per unit time, so you are going to define a unit time per day, per week, etc., etc. So you can develop some kind of a C chart and then keep a monitoring of that, any abnormalities are there, etc. So control chart for attribute data that can be used in absenteeism monitoring, etc. Then you have the correlation scatter diagram analysis. So you are conducting the, possibly when you are recruiting, the conducting the test and the job performance. So some test score against the job performance. So is there a correlation? And kind of, in such cases, which are the test scores which have a higher correlation. So whether all the tests need to be given or some tests can be need not be given, because if that is not going to have a performance, if kind of, relation with the performance, why unnecessary waste time, etc., etc. So you can do this kind of a correlation analysis for the various test score versus the performance score. Similarly, possibly you can do a DOE, think of a DOE application for recruiting process. Conduct a DOE on those factors that affect the recruiting process. So here your response to study would be the recruitment time. Factors may include, so your for a particular position, the recruitment time is your response. Maybe that may depend on the advertising sources, the type of ad, size of the ad, or what personal agency through which you are going, etc., etc. These are all the maybe the influencing factors, so whether we can kind of, decide where the here the recruitment time should be shorter, lower is better. So whether any possible DOE applications you can think of in the recruiting processes, defining the recruitment time as the response variable and the factors affecting the recruit time, the variables affecting the recruitment time as the factors. And again, multiple regression, you can think of job performance built with scores based on certain predictor variables. So the job performance will depend on, possibly HR can think of the various variables and then try to have some kind of a prediction equation, the predicting the job performance based on certain background variables. And logistic regression is another useful technique, especially for retention or attrition analysis. So develop using the logistic regression model, we can develop a predictive model developed to predict the individuals who have a high chance of leaving, who are at risk of leaving, and what are the surrounding factors, maybe the decisions. There are so many background variables we collect. So the age may have a role, gender, salary, satisfaction with the immediate supervisor, proximity to homes. There are so many background variables we may have. So possibly we can have a kind of a analysis. We have some data already. We have the past data about so many employees. I mean, with reference to our employees in a particular, let us say, when you are doing the attrition analysis and you want to reduce attrition, and you find in a particular job category the attrition is more, and you already have the data from your earlier database. So you define some kind of, if a person leaves within 2 years, right, you call that as a zero variable, and if he stays longer than, you call it as a person is likely to stay longer. Say, so y takes the value 0, 1. Already you have the background variables, several background variables, and we can build a prediction formula. And for an individual, for all the individual, we can have a prediction formula among the people who are likely to leave, who has a high chance of leaving, using the logistic regression model. Possibly we can think of how to retain them, or how to have the retention of those guys, etc., etc. So this kind of attrition analysis or the retention effort we can use logistic regression type of tools. So these are all some of the applications that we can use, simple as well as some advanced tools in the HR area. Similarly, in the purchase, you can use the simple tools like a trend chart, supplier on-time delivery performance. You can have the, of course, what is on time, you have to define it. So having defined that, so supplier on-time delivery performance, how the trend looks like, material quality, so the percentage of parts that meets the standard, that do not meet the standard, you can have a kind of a trend chart. Then supplier response to inquiries. The chart would look for trends in the length of time it takes for the supplier to respond to an inquiry. The inquiry could be a request for information or a request for quote, whatever may be. So for your inquiry, how quickly the supplier responds. So some kind of a trend charts and how does it look like. Control charts, the similar application for trend chart, and normalized control chart, that is purchased price versus the standard price for an item, purchased price versus the standard price for that item, which you can get from the standard cost, etc. So look at the abnormal trends in pricing and then take some action on that, etc. So this is a normalized control chart, normalized against the standard. Then in the customer service area, of course, you can use the simple tools like Pareto diagram, complaint analysis, return product analysis, order error analysis, invoice error analysis. Of course, I'm not going to go through completely. Of course, I can share this with all the participants. So I'm not going into the details of how the Pareto should be done, etc., etc. So these are all the possible applications. Then the order error, invoice error, etc. Here, one of the simple tools like your concentration diagram, one of the check sheets what I was mentioning you in the beginning, concentration diagram. So in which field the errors are frequent, in which location the errors are frequent, that can be found out, and then say how, why such errors are happening, and then how to simplify, etc., etc. So you can use the simple tool like concentration diagram for tracking the order error, invoice errors, etc. Then run charts, trend charts, these things can be also used for on-time shipment, on-time delivery. Shipment is leaving your premises, delivery is at the customer place. So on-time shipments, on-time delivery, on-time service. On-time service is the ability to meet the customer initially requested, the how far we are able to meet the customer's delivery date, irrespective of how realistic or unrealistic it is. So you can track that. So on-time shipment, on-time delivery, on-time service, then complaint analysis, then response time to the customer information inquiries, response time for the request for quotation, time of order placement to the receipt of payment. So for all these things, you can use the trend charts and then see how the trends are, and then any abnormalities observed and what kind of an action plan you can think of, etc. So these ways, all these simple tools can be made use of. And the similar thing, you can for the similar application, you can use the control charts as well. Then in material control, you can use Pareto diagram for raw material outages or raw material shortages. Make the diagram by product and by cost for those raw material outages. Then truckers performance, Pareto on-time performance of different trucking firms, and then who are all generally you can identify, and Pareto can be used. Then trend charts for raw material inventory level, work in progress inventory level, then finished goods inventory level, then inventory accuracy, that is if there is a kind of deviation in what is physically found and what is supposed to be there, etc. So calculate the percentage of actual difference from the inventory control amount and the plot on a monthly basis and then see how the trend is. Then daily shipment value, response time to material request from the shop floor to your supply to the shop floor. So plot the average time from request for material to delivery from the warehouse, etc., on a daily basis or weekly basis, etc. So trend charts and the similar applications, you can use it for control charts as well. Then in the maintenance area, Pareto diagram, you can use it for equipment downtime, process downtime, maintenance effort, that is the hours spent on maintenance by process line or by department, etc. So for downtime of the equipment, process downtime, maintenance effort, for these things you can use Pareto chart. Similarly, parts or supply outages, there is a kind of supplies by those run out for the most frequently, that is maintenance, what are the spares you require. Then the trend chart for time to complete your work order. So plot weekly or monthly trends on the average time or maximum time it takes to complete your work order. Then time to failure analysis. So here, how the machine breakdowns happen. So what is the time between the moment you put the machine back to work and how long it works, etc. So plot the time to failure for key pieces of equipment. So the x-axis would be the failure number and y-axis would be the time since the last startup from a repair. This information can be used. Of course, based on this, the time to failure can also be used for predicting the reliability of the equipment, mean time between failures, etc., etc. So some of the advanced topics like reliability concepts can be brought in if you know the time to failure. Apart from normal summarization of data, we can give a kind of a predictive modeling about the reliability of the equipment and then the mean time between the failures, which can help you to establish the preventive maintenance intervals, etc. Then ratio of what you can also see the trend in ratio of hours spent on preventive maintenance to the hours spent on emergency repair. So how much you spend on preventive maintenance and how much hours spent on emergency repair, etc. So this plot can help you. A downward trend is dangerous, indicating emergency repair or overtaking the preventive maintenance efforts, etc., etc. So you can study the trend and then see how we can take certain corrective actions, etc. Similar usage of control charts, similar to your trend charts, control charts can be used. Then you can use the normalized control charts also to monitor. Normalized control charts means the time actually it has taken against the standard time for the normal repair. For a normal repair, what is the standard time it should have taken and what is the actual time that is taken, because each type of repair may not have the same time standard. So simply plotting the time of repair may not give you, so you have to standardize to the standard time for a particular a class of repair. So the time to complete a repair normalized to the standard time for that kind of a repair. So this kind of a data may be available, published sources are available for common type of repair, etc., etc. So based on that, some kind of a standardized control chart you can plot and see how the trend is and how the normalized control chart looks like, any abnormalities are there, etc. And of course, safety and environment, you can use the concentration diagram, environmental incidents, a separate concentration diagram of the facility where actually the environmental incidents or example spills, etc., occur. Similarly, injury location, you can think of kind of which part of the body frequently you have the injury, so that how we can improve the safety aspects, etc. So draw a, like normally in a concentration diagram of a in the shop floor, we have in the check sheet, we have a component diagram and the geographical locations are marked. And whenever a particular type of defect occurs, the location is marked and the type of defect is also marked. So that kind of a summary will normally help you which are the type of defects which occur frequently and in which location such type of defects occur more frequently, because all the defects may not occur in all the locations. Similarly, in the accidents also, which type of injury, where exactly is happening, such kind of information may help you to improve your safety standards, etc. So similarly, you can use the accident analysis, environmental incidents, etc. Similarly, you can use the Pareto diagram for the same purpose. So this is about some of the simple tools we can use in this area. So these are all basically what I have tried to summarize here is basic tools as well as some of the advanced tools, how we can think of some possible application in which area, which tool, for which characteristic, and what are the possible ways that you can make use of. That is what I have summarized. And generally, uh, we have not seen that much of application of the tools, though they collect some data and then they present it through some tables, etc. But in the non-manufacturing area, we have not seen many applications of the tools. Yes, manufacturing, yes, you have extensive application, and that does not mean the tools are applicable only to the manufacturing. It's true, because the whole thing started when you trace the history. Schuhart, who introduced the control charts, he initiated the process control chart because he wanted to have a good control of the process so that you can avoid inspection. So manufacturing was ahead of applying these tools compared to other areas, but that does not mean the tools are applicable only to the manufacturing area. So that's generally the kind of a perception, though we have some applications here and there, but we don't see that much of a application in other areas. Possibly we can think of and encourage our other colleagues to use these kind of data-based tools for making more objective decision, because as a TQM practicing company, we know that all the TQM advocates the usage of all the good practices and the application of improvement tools company-wide, not just in manufacturing. So with that in mind, we can possibly with this whatever I have summarized, and you also may have based on this, it may trigger something in your mind also. We can keep those things, and we can encourage our other colleagues in other areas to think of applying this kind of a tools. So this is what I just wanted to share with you. Now, possibly the next 5 or 10 minutes, we can have some kind of a discussion, or if you have any doubt, I can clarify to the best of my ability. Hello.
Thank you, Professor.
Yeah.
My name is Vinod Kumar Rajendra, part of ISQ Chennai chapter. Thank you for a very insightful session. So let me facilitate the Q&A session. So there are a few questions from the participants. So let me channel those questions for you. Is that okay, sir? Can I call out the participants to have their questions?
Vinod?
Yes, sir.
Simply for the sake of timing control, more than anything else, you can read out the name of the participant and the question.
Okay, thank you, sir.
Because we have limited time, maybe this would work out for us right now.
Sure. So
No
the first question is from Pradeep Kumar Sharma, Tata Power Delhi Distributions Limited. So his question was to give some more elaborate use of Z test, the Z test, on some specific examples.
Hello. Hello.
Yes, sir, you're audible, sir. Please go ahead.
Yeah, what is the question? I'm not clear.
Okay. Good evening, Professor. Can you please elaborate more on the Z test with some specific examples?
Is that test?
Z test, yes.
No. Is that test is basically done to compare the relation between X and Y, where X is having two categories and Y is a metric character. Suppose, let us say, I have two methods of training. Okay, I feel the one method is superior, it gives a better input than the other method. Okay, so I similar participants, similar background, I put them into two kind of groups. One group goes through one type of training, other group goes through another type of training, and then at the end of the training there is a performance test, and we compare the two methods of training with reference to performance score. So performance score is a Y variable which we have measured it. Method of training is a categorical variable. We tried two methods, and who will go to one method, who will go to the other method, we randomly assign from the new recruits, etc., etc. And then we test whether the average performance score in training method 1 and the average performance score training method 2. If there is no difference between the true training methods, the average score should be more or less same. And our suspicion is one method is better, so we try to test the hypothesis. So here we use Z test, okay, or T test. Hello.
Thank you, sir. Thank you.
That is, I am trying to compare two groups with reference to a measured characteristic on the average, whether the groups have the same score or not with reference to some performance characteristic. So that's where Z test and T test are used. Now again, why Z and T? And in Z test, there is an assumption that you have a prior estimate of variability in the scores is known, whereas in the T test, we assume that variability is unknown. That's all. So if you assume variability can be taken as a known because previously we have done the method, so that we can assume that from the past data we have some estimate of prior estimate of variability is available. So if you think that prior estimate of variability is available, we can use Z test. Otherwise, we can use T test. So comparing two groups with reference to a performance characteristic. Groups are based on some categorical variable. It could be male, female, different type of training, or different, let us say, different type of treatment. Say I have one type of treatment and another type of treatment, and as a doctor, kind of I have a suspicion that type 2 treatment will lower the blood pressure faster. Type 2 treatment will lower the blood pressure faster. So this is my kind of hypothesis. So I am trying to kind of, some kind of samples I administer for one group. One type of treatment is given, another group, another type of treatment is given. I monitor the blood pressure and then say that after how much time it gets reduced. So such type of situations is Z test or T test.
Thank you, sir. Thank you very much. The next question is from Kunal Parikh, and the question is, how can we use cluster analysis for identifying customer segments in power distribution?
In
power distribution.
Customer segment in power distribution, in the sense based on the customers, what all the variables that you are measuring. Hello. See, I have a group of customers, right? Okay. On those customer with reference to your power segment or a power sector, on the customers, what are the characteristics that you are measuring? See, when you do clustering is based on some measured variables. So what are your variables? In the power sector, what are the variables you measure on the customer? Do you have any variable?
Yes, sir. This is Kunal here. So, sir, what we usually capture there is that what is the contract load of the customer? What is the annual or monthly consumption of energy? Then we also have the area where the customer is residing.
Yeah.
And we can also these are the three. I think that's what we capture. Otherwise, we'll have to take more variables than that.
See, if you have certain kind of 3 or whatever it is, 3 or let us say 10 number of variable, doesn't matter. So we can group them. Who are all the customers who are similar with reference to these variables? Who are all the customers? They are. So how many different groups they form into? That can be easily worked out.
Understood, sir. Thank you so much.
Yeah.
Thank you.
Thank you, sir.
So what I'm trying to say is, as you have mentioned, with reference to the power consumers, I can segment my customers who are all similar with reference to the load usage or whatever it is. You have mentioned about 3-4 variables. With reference to these variables, these are the customers who are all similar. So they can be one group. That is another group forming. Like that, we can form the groups.
Thank you, sir. Thank you very much.
Thank you,
in the
sir.
interest of time, I will take 2 more questions from the participants. Already those questions are channeled to me, so I will take the questions. Others, if you have any questions, you can write to us. We will take the feedback from Professor later. In the interest of time, let me have the last 2 questions. Sir, the next question is, which statistical tool can be used for analyzing customer review feedback on products?
Customer
question. Customer review / feedback on products.
Customer review, is it?
Yeah, review.
Customer review on feedback. So how are you getting the feedback? Customer review. Are you asking him to rate you?
Possibly, yes, sir. So there is a survey from where we are getting the feedback. I'm not sure. The participant has not given the full details, but I assume, yes, we are getting feedback from the customer, and that is in terms of customer feedback rating. And the participant would like to know a tool to analyze the feedback.
No, that's what I'm trying to say. Customer feedback, you want to analyze with reference to what? What is your objective? You are taking a feedback. So there is a feedback score, right? Hello?
Yes, maybe I would request. I would request the participant. The name is not displayed properly. Can you please unmute and explain or elaborate your question so that you can get a answer?
Hello.
Hello.
Hello, sir. My name is Swansthi Tiwari. Sir, basically this question is about the customers given a reviews on basics of the point. Example, if there is a 5 points and customer giving to 2 to 3 points. So how we
customer
calculate this?
Gives you
base.
No. 1 minute. 1 minute. You are doing a customer satisfaction survey.
Yes, sir. Yes, sir.
Right. So there is a satisfaction score.
Yeah.
Right. Now on the satisfaction survey, what are all the aspects that you are asking to the customer? What are all the aspects?
Sir, it's about product feedback.
Hello.
Example, if sir, it's about a product feedback. Example, there is a point from 1 to 10.
No. Your voice is breaking. So what are all the information you get from the customer in your survey questionnaire? What is that? One is satisfaction score, right? Apart from the satisfaction score, that's the end result. Okay.
So who is the HOQBM, please? If I may intervene, Vinod.
Hello.
Just permit me to just for a second. Who's asking the question, please? Your good name?
Hello, sir. This is Swansthi Tiwari.
Sumant, just hold a moment. Let me explain. If it is different from your idea, please elaborate to Professor Iyer. Sir, the question is, this is about a product survey. Okay. So they are possibly asking the customer their feedback on different aspects of the product. It could be weight, it could be color, it could be.
1 minute,
yeah.
sir.
Yeah.
You are asking the satisfaction of the customer with reference to different aspects
of a product.
So yeah, let us say there is aspect number 1, aspect number 2, aspect number 3, like that. How many different aspects are there? Let us say 10 different aspects or 5 different aspects.
Yes.
Now you take over, Sumanshu.
Hello.
Yes, sir. There is a yes, sir. There is a different types of the website for 3 to 4 website, you can say.
Okay, you have 3 to 4 aspects. Okay, right?
Yeah.
Hello.
Yes, sir.
4 aspects, sir.
Yeah, you have 3 or 4 aspects on which customer gives you a rating and also gives you overall rating, right?
Rating. Yes.
Right.
Yes, sir.
Right. So you can think of some kind of a multiple regression type of thing. Overall satisfaction score is a function of the score in the aspect 1, aspect 2, etc., etc. So possibly you can say which are all the aspects kind of dominates the overall score. So where you need to improve, etc. Whether any negative, the lower the score there, adversely impacting the overall score. So a multiple regression type of thing, you can do that. Hello.
Question is answered, sir.
Yes, sir.
Hello.
Okay.
Hello.
Try multiple regression if you have such inputs from the customer.
That is, let me again clarify you. My customer survey consists of, I am asking about his overall satisfaction and I am asking his kind of a perceived his opinion about my various aspects of the product. Let us say aspect X1, X2, X3, X4, X5, etc. How my overall satisfaction score is influenced by the customer's perception scores on these 5 or 6 aspects, and out of these 5 all are equally important or some of them are more important, how it comes out. So which are the aspects which consider which customers in customer's perception which are more important for his overall satisfaction score, etc., that can be brought out, and those aspects possibly you can think about improving the score. So tool type multiple regression should be should help you.
Okay, sir.
Thank you, sir. Thank you very much. So for all the other participants, we will have this session uploaded in our channel as well. So you will have opportunity to listen to the recording one more time. And if there are any questions, we are very happy to channel your questions to Professor and get the feedback from Professor. So let me hand it over now to Vishwadeepak for vote of thanks.
Vishwa, just a second, Vishwa. Friends,
Sure.
if you all of your questions, this window will be open for about 10 days. Okay, so you can send the questions to Mr. Prabhakar, from whom we will gather the questions and pass it on to Mr. Iyer and we will revert to you with the answers from Mr. Iyer. Okay, the window is open only for about 10 days from today. Please. Thank you. Vishwa, take over, Vishwa.
Thank you. No, it's all right, sir. Thank you very much. Thank you, Vinod. Professor V V Iyer, I would like, or I will take this privilege to thank you for multiple reasons. Actually, I have multiple reasons. One, for sparing out the time to enlighten us and our participants on this subject. And another reason for thank you is making this subject so easy to understand. Normally, when we think about statistics, some kind of fear is coming into our mind. But you made this subject so easy to understand, very much simplified, and the way you have given the examples to all of us, that has really create a good interest to application of even higher statistical tools in our areas other than manufacturing. So thank you very much on the behalf of ISQ Chennai chapter.
Thank you. Thank you.
I would also like to thank Dr. Rajkumar for setting the context and Mr. V Sundararajan for giving the wonderful introduction of Professor V V Iyer and all my ISQ chapter colleagues who put their efforts to make this program successful. Last but not the least, my heartfelt thanks to all the participants who have spared out their time on this Saturday evening and made this program a very successful program. So thank you very much to everyone who has attended this program and contributed to the success of this program. Have a nice weekend ahead. Thank you very much.
Okay.
Thank you, Shwa.